Okay, chapter 9.1 is about the parabola, and what you need to know just right up front is that they are looking at not only parabolas where we have a parabola that opens up or opens down, but we're also looking at parabolas that are oriented around the x-axis that open left or right. Okay, so when they open up or down, we have x squared, and then when they open left or right, we have y squared. All right, and that'll help kind of explain what we're doing here. So I want to refer you to page 739 in the book. I basically had this page open every time I worked a problem like this. In fact, I'm going to open the book. Hang on. Okay, so this is page 739, and I basically had this open while I was working on this. Now I'm going to copy some of this to our work, but that was my reference. I strongly suggest it. All right, so they refer to these equations in standard form, and as usual, they have a slightly different version of standard form than I've seen before. Because this equation has y squared in it, the standard form for that kind of equation is going to be y squared equals 4px. Now, what we also know, without any addition, subtraction, in our equation, there's no left-right translations or up-down translations. So when we're in this form, we know that our vertex is always going to be at 0, 0. So we can just start with that. Okay, what we need to do is I'm going to solve for y squared on this one. 5 by 5. And we get y squared is equal to 1/5 x. You definitely want to separate that because remember, we've got this idea here. We've got this number p, and it is used in a lot of what we do. So what we need to do first is solve for p. So we take whatever number, once we solve for y squared, we take whatever number is in front of x, and we set it equal to 4p, and then solve for p. I don't want to divide by 4 because I've got a fraction on the left-hand side. I'm going to multiply by 1/4. That gives me p is equal to 1/20. All right, I'm going to use that to answer the questions. So the focus is, when it's oriented left-right, when we have y squared, the focus is going to be at x equals p, y equals 0. Okay? So I've got 1/20 for p and 0. There's our focus. And I also refer you to the drawing to figure out what the focus has to do with our parabolas. There is another piece called the directrix, and that is found at y equals -p. So this is the equation of the line called the directrix. For our equation there, it's going to be y equals -1/20. And the axis of symmetry will be found at the x-axis, because we know we're at, our vertex is at 0, 0. The equation for the x-axis is y equals 0. And we are done with that problem. Okay, the next problem is the same idea, only we have an x squared. So our standard form when it's x squared is going to be x squared equals 4py. So we're going to take this equation and we're going to solve it for x squared. And we get -4/3 y equals x squared. And we're going to do the same thing and solve for p. So 4p is equal to -4/3. And I'm going to use a reciprocal again because I have a fraction over there on the other side. So it looks like in this equation P is equal to -1/3. Okay, so things change a little bit. Our x's turn to y's. You'll see what I mean. The vertex again is at 0, 0 because we don't have any left, right, or up, down transformations. Those will show up in the next problem. Our focus is at 0p, so those two coordinates switch when we go to x squared. So our focus is at 0, -1/3. Our directrix is the same idea, only now it's y equals -p, +1/3. And the axis of symmetry is the y-axis, and that's going to be at y equals 0. All right, that does it for this video. We'll see you in the next problem.